Through the Noise, the business of communicating. This podcast is presented by Human Factor, providing award-winning music, sound design, and post-audio for all media projects. And Infomia, providing online strategies for associations and institutes, ensuring their projects get noticed.
What's up?
Hey, back to Through the Noise.
Yeah, Blake?
We're going to go more than noise, though, today.
I think so. We're going to go...
Video!
Paul is in the studio. Rick is somewhere.
He's going to be in a second, because this demo needed, you tell me anyway, this demo needs a
visual component.
A visual component, because we brought with us, let's do a dumb setup. You don't really think, I was listening in the car the other day, and I was thinking, man, you get a lot of 3D movies. When really you hear about 3D audio?
Is it even possible?
And whatever happened to all that goggle stuff? And
I don't know, but I decided to call my friend Adam O'Donovan.
And he walked in.
How you doing?
Hey, man. Hey, hit the...
Oh, we went to the door? All right, so he came in.
He's in. What's up, Adam?
So,
hey guys,
for anyone listening, there's going to be a video element of this, probably the next podcast down or something. We'll figure out a way to get it up.
We're going to add it to the site,
yeah,
the website or something. But Adam O'Donovan is the Chief Technical Officer at VisiSonics.
That's right.
And we've been talking about having you on the podcast for a little while. And I finally got you in here with all this gear.
Yeah, we got a lot of gear.
Yeah.
So let's go into the gear. I mean, I see a disco ball... Or the thing that goes in the planetarium. No, the planetarium thing, that shoots up, and a computer, and I saw some goggles, and I know kind of what this is going to be about.
Yeah, what's that?
All right, so
let's
what
go through
this is we call it the 564 panoramic audio camera. So it's a spherical microphone array with 64 microphones and 5 HD video cameras. So with this, we can record not only just the sound, but also all of its spatial content, so that we can render it back with all of 3D information included. We can also capture panoramic video, so you can use it with head-mounted displays and really get experience playback with full 3D audio and head-tracked video.
All right, that sounds cool. I don't know what any of that means yet. But so what does that mean in the practical world? I mean, maybe we could just dive into a demo, but maybe we should get a little more info. So what would an application be?
So one application, and an early applications that we're actually looking at, is just analyzing sound fields, right? So when you record a sound field or an environment with a single microphone, you lose all the information about where that source was in the environment, right? But
like our podcast right now.
Yeah, exactly. You don't know where any of us are in the room just by listening to
in the
us.
left ear or the right ear.
Yeah, exactly. And so when you capture with an array of microphones, you actually capture all of that spatial information as well. And so one of the applications is to identify where noises are coming from in space. So for instance, if you have a car that you're designing, a luxury car, and you want it to be as quiet as possible inside the cabin, you need to know where sound is leaking through from the road, from the tires, from the wind, so that you can mitigate it. So you can add foam or dampen it. And so this tool actually allows you to visualize the acoustic distribution of energy in any space. And so a designer or industrial analysis firm can utilize it to immediately visualize where noise sources are in the space.
Visualize meaning I can actually see it.
Yeah,
I can
exactly.
See where it's reflecting or how that works. And I guess that's why we have the cameras today, because want to show this little laptop screen you got going on.
Yeah, absolutely.
I think that's where you start to get an idea of what's going on, right?
Right. So on this screen,
I'm gonna move
we're
over.
seeing now is the panoramic video display from the audio camera. So here we see not only this 360-degree video, but we also see this overlaid color map. And this overlaid color map is actually the acoustic distribution in the environment. So as I'm speaking, you can see my face is actually lighting up.
Wow. I just thought you had a fancy teeth or something, but that is, so you're, look at me.
Exactly. So every time you speak, we can see exactly that the source in the environment is your mouth.
Is it working? Hey, is it working, Ernesto?
Yes, it is. It's actually showing
I'm going to try to fool it. Can I go under the table or something with that?
So what we'll see is we'll actually see the path that the sound is taking as it refracts around the table.
What's it doing?
And bounces off the walls.
It's reflecting all over the place, like underneath the table, around the corners. That's awesome.
Yeah, so if you're analyzing listening spaces like this, in fact, What you can do is you can utilize it to visualize reflections. So if you want to know if all of this sound dampening stuff that you've got on the walls here is having an effect, you could take it down, make a clap, watch how that clap interacts with the space, put it back up, and do the exact same thing and see how it's been modified by all of that.
Hey, Ernesto, walk over there. I want to see
treatment.
it.
Okay.
All right, so Ernesto is getting up.
So
Oh my gosh, look at that.
yeah, it's pretty cool. So we could, if you had a consistent sound source and you wanted to absorb it in the right spots, you might put more dampening material off the reflections of the ceiling or wherever else
Exactly.
it's reflecting on.
And so you can see even while he speaks, you can see a reflection off the table when he snaps.
Oh, yeah, look
Hey.
at that.
You can see a reflection off the ceiling.
Whoa.
And so you can identify what the path is of each one of these sounds.
Trying to fool it, but I can't because it's really good.
So that's why you would you would stick this in a car,
Right.
one of those luxury models where you want it to be totally silent from the world, right?
Exactly.
So you're in your own bubble. And you run the audio, run the car, run whatever, drive it around, and pick up, record the audio, and in a visual format, you're able to see where the reflections or what's vibrating or what's coming through.
That's exactly right. So if you, let's say that you just throw it in there and you drive on the highway, you're going to have noises coming off the tires, you're going to have wind noise coming off the mirrors. You can immediately see where that's leaking through. Is it coming from the footboards? Is it coming through the dash? Where's it coming from? It's coming through the doors, the window, and then get some insight into where you need to do your treatments to
But
make it quieter.
can it zero in it? What if there's like a what if it was what if I'm in a noisy room? Wouldn't it just be light everywhere?
Yeah, it can be. So if you're in a really reverberant environment where, there's no absorption on any of the walls, and in fact, they've got chambers like this, call them reverb chambers, where you're intentionally trying to make it as reverberant as possible. You'll see all of these multiple sources, these image sources, right, all over the place. The strongest source will be the brightest, but in reverb chambers where you're trying to make all of the reflections as strong as the strongest source, you'll see them as secondary reflections. And so in that way, it becomes a useful tool for actually visualizing reflections. In a space like this, you've got a lot of dampening stuff up on the walls, so you tend to see only the direct sounds because they're absorbing a lot of the energy off each one of these reflections.
So it's a testing device then, mostly.
As well, yeah. So right now, what we're doing is we're selling it into, basically the acoustic analysis world. We've sold it into, a couple of universities doing research in this type of thing. The other thing that you can do when you've got this much spatial information is you can actually selectively listen in a single direction. So it sort of like creates a virtual, highly directional microphone that you can steer digitally.
So can we try it? We rigged it up.
man.
So we're gonna switch over to your machine.
Yeah.
Should I stand up? What should I do?
Yeah, so in fact, here we can all talk simultaneously. So what I'm doing on the screen now
I'm over here, right?
is I'm clicking on a pixel. And right now the pixel I'm clicking on is myself. But I can steer this around the room to anybody in the environment, and we'll isolate that. So if we all talk simultaneously, I can bounce back and forth between us, and we'll see how much isolation that we get. So
again.
We want. All right. So that's after. No, that's after we. You're impressed. Ready?
Okay.
All right.
so maybe I'll count. One,
let's all talk about our
2, 3,
drive-in.
4, 5, 6.
Driving in today, I was coming in, and
Traffic
it
was really good on the way in today.
awesome. All
It was-
talking to. I mean,
21,
really
20, 22,
That's the
23,
thing, because I don't know what to say. Elton's talking.
There are creepy people on the metro
He played
sometimes.
Ernesto, and he can't back back at me because he has to try to hear what I'm saying.
Yeah, hey,
you have to insult me while I'm insulting you, you bastard. You're a terrible person.
That's what you would need.
I need a haircut, but I'm in this podcast. My haircut. I don't know when we have to
42,
stop.
43,
How long do we have to keep
44,
doing this?
45,
I can hear the radios turning off.
47,
The
48.
iPhones are turning off.
Are we good?
He's laughing. So this must be riveting for one person.
Oh, no.
I'm sneaking. I'm listening. What's he got going on over there? Oh, he's just hearing me. It's just me.
Oh, so you are jumping
And
around.
I can switch back to myself.
You were jumping
So-
around between us.
Yes, exactly. So I'm hopping back and forth. Between each of us. We've got a little window here that shows what you're listening to. So right now it's myself, but I can pop over to Blake.
Hey, I'm just going to run over here. Ha, I'm fooling you. No, I'm not.
But you're doing it with the mouse, right? You're sort of
Exactly.
pointing at where you want, and you isolate what he was saying versus everyone else's sound reflections.
Exactly.
He's pointing at my face.
Exactly.
Yeah. So he was able to hear you
talking while I was talking, but you could hear him specifically because you had pointed to him as a source.
Exactly.
Holy crap, that's awesome. So you can use this in security or some kind of
Exactly. Surveillance,
So how sensitive is it? Like if we had 50 people talking.
So basically, what the array can do is it can suppress spatially every other direction that you're not looking at by about 25, 30 dB across the board. So if you've got a ton of really loud distractors up close, and you're trying to listen to somebody far away, they may be 70 or 80 dB lower than you, so you're not going to be able to boost them up enough.
Okay.
But in an environment like this, where all the sources are about the same
Consistency
and the same level, you can do a really good job of isolating.
That's fantastic. So I wonder if you could get a. That was great. Maybe at a casino or something where you're trying. Yeah, they have all those video equipment, but the arguments get heated. You could have one of those things, sort of like
Who started it?
Point to a table to listen on what's going on over the.
Exactly. No, that's exactly right. Anytime where you might want to be able to go back and reconstruct what happened, because the nice thing is if you've made a recording with this, that steering that I was doing live, I can do after the fact as well, because I've captured the whole field.
There it is.
Right. Right. Okay, so that was pretty cool, and I don't even still taking this in. Like I'm.
Yeah. So you're going into the. The car industry is one of those areas that you were looking at. But
That's right.
Are you exploring any other possibilities for?
Yeah. So the other side of this technology is once you've got the ability to extract all the spatial components, you can imagine creating sort of a 3D soundscape. Because, imagine a Dolby 5.1, you've got 5 channels representing each of the different directions. We could generate that from a recording from this just by pointing at where those speakers would be. Or we can do better, we can create a complete panoramic 3D scene. And so that industry is in sort of the experience capture and recreation. And so I can throw a demo up of us live, another one. This will be
live one?
So instead of me clicking around, what I'm going to do is I'm going to switch it to a sort of a 3D sound mode. So now,
Okay, I think that's working.
yeah.
You take
so
your headphones
now-
off because it's a little bit of latency.
Yeah, there's a bit of latency on this. But if I now walk around the array, you'll be able to hear the side of the array that I'm actually on. Test 1, 2. Test 1, 2. Test 1, 2. Test. Right here.
The camera?
Whispering in your ear.
All right, there we go.
Yeah. Whispering.
Hey, there's some
Test.
guy whispering in my ear.
So now when we're recording all this spatial information so that we can play it back with, I can tell that I'm now standing on the right side of the
Feels
array.
like you're behind me.
Exactly.
Oh, my own voice is kind of strangely distracted. But
It is. So when you're in the same room with the array, you hear yourself coming from a strange direction because you're outside the array. But when you listen to it in playback, you'll be able to tell everywhere that people were in this environment.
Does it work only on headphones?
Our technology right now works only in headphones. So
Okay.
we're focused on recreating experiences for headphones, which right now have been using technology from, 60 years ago, stereo technology. So you can imagine listening, to a movie on Netflix on your iPod. Why not have a
On the
completely immersive environment there where you have full 3D sound better than a theater, Or you could watch a recording that you made with a spatial camera or that was made at an interesting place like Times Square and get a real experience that you're somewhere else. And so that's where...
podcast.
Yeah.
Or podcasts?
Hey,
So that was an example of the sort of audio that we can capture, but we're also capturing panoramic video. So we've made an interface where we can utilize something that's been recorded and look at it through a head-mounted display with head tracking. So I'm going to queue up a demo of that.
We got an Oculus Rift to play. Yes.
I don't know what an Oculus Rift is, except I've seen it, but I didn't know what it was before I came in today. You know what it is, Ernesto, so
will.
tell us what it is while he's loading up.
I don't know much about it. I'm gonna let Adam talk
It's
about
like
it.
Oculus Prime. Oh,
Oops.
I bet.
yeah, that's my friend's band.
we gotta try
All
this.
right. So now,
So
kick on this
wearing
head-mounted
this
display.
Okay.
Yeah.
Ernesto now has some sort of camera on his head. Or not camera, like a virtual reality thing, and he's looking around the room,
So I'm in a bar.
and he's in a bar.
You're not, but I'm not in a bar.
Is there drinks?
Yeah, dude. I
What
feel
do
like I'm in this bar. Not this bar. This is Harp and Fiddle, of course, in Bethesda,
That's right.
where we play poker a lot. This is awesome. God, and it's like I'm in it.
Exactly. So what we're trying to do is capture the completely immersive environment. So it's not just a stationary video. It's everywhere. It's all sounds coming from all directions, and it's all possible views that you could take in that environment. Then we can render that based on the head orientation onto the head-mounted display, and also render it to earphones.
So what's happening is
the band's
Ernesto
all the way over
thinks he's in a bar.
It feels like I'm in a bar. Here, take.
All right, hold on, I'll try.
You gotta try this.
I want the whole rig. Hold on. You gotta tell me what's happening.
That's my bar. It's a nice bar.
Who's the chick? Where's everybody?
It was
Oh,
a
I
slow
see.
night.
So it's a little blurry though.
You're not a human
so
factor anymore.
right now the resolution of the head-mounted displays is low.
Where's
but-
that band? Shut up. Who's the band?
So right now it's behind you.
Oh, it is.
Now it's to your right. There it is. They're off in the distance.
Oh, I see them.
Yeah.
It's awesome.
So this is a band called.
Oh, I see it.
One
No,
Man
but
Bridge.
you gotta get the goggles like right on. They're a little low for me. So now I see it
there
better. Wait, they're behind me.
That's the other side of the bar.
Yeah, I'm gonna drink. I want that guy's drink.
When did you do this?
This was actually last night.
last night. Okay.
Yeah,
You brought the planetarium thing out to the.
I did. Yeah. So I was trying to get some examples
chicks like
for
that?
this. A lot of people were pretty interested in what it was.
You guys want to take a look?
They'll look after. Hold on, we gotta keep.
All right, I'm going to kill this one.
All right, I'll pull it back. So that is pretty darn cool. So you just sat in a bar with a martini, and you're not. Are you hiding under the camera, or you just went away from it? 'Cause
That one, I was standing up. I was actually reading the Declaration of Independence in the background to see if I could pick that out with the sound isolating technology
And it's
amongst
just
the
with
noise.
that mic. You just brought the mic.
I just
Mic and a
brought it, made a
laptop.
quick
Is it-
30-second recording. Yeah, on the laptop.
and it makes a bunch of WAV files, I guess, and then somehow does. I don't even know what this word means, but does an algorithm.
That's right.
Yeah.
That's right. So
always hear
basically,
that.
we designed this to try to make it as easy as possible to deploy. So usually when you're dealing with a bunch of microphones, the classic architecture is that you got a huge analog to digital front end, maybe even a rack. You've plugged in a whole bunch of analog channels into it, and then you finally feed that to some kind of capture device. What we've done is we've got all of the analog to digital conversion going on inside the Sphere, and then we take it down to USB 3.0. So we've just got a single connection that goes from
The camera to
this
the laptop.
entire camera to the laptop, and then
Okay.
the laptop extensively uses the graphics card to do all of this processing in real time. Because there's a lot of processing of data. This thing is streaming. That 30-second recording is a gigabyte. So there's a
Okay.
lot of data coming in
it's
in
a
raw.
lot.
Yeah.
Man, that's pretty slick. What? Where can I get one? Can I get one at Best Buy?
Not quite yet.
Oh.
Right now, you got to come to us.
So what else? I mean, okay. So but that's the mic itself, and then you have some other technologies sort of.
That's
associated
right.
with
So
this,
this is a device. So you can imagine if you're in a live environment where you don't know where people are, you need a device like this to capture all the spatial information. But if you have a virtual environment, like for instance a video game, where you know where all of the objects are in the environment, we have an engine where you can basically feed the sound you want it to play and where you want that sound to be. So in a virtual world, you don't need a microphone array. You don't need any hardware at all. You can just use a software engine to directly mix 3D sound.
That's interesting. So, because now you can play a video game, mix in the sounds of the video game itself, and make it 3D.
Exactly. Exactly. So then you get a completely immersive environment rather than, basically game designers are constantly trying to make more and more and more immersive scenes. And so a lot of the research that backed this company, I should tell a little background about maybe where we came from. So this technology was born in the University of Maryland under the research of Ramani Duraswamy, who's my co-founder. He was my PhD advisor, and we both founded VisiSonics. While he was there, he was developing algorithms for creating virtual environments for newly blinded soldiers. So if somebody came back from war and was newly blinded, they had to be trained how to navigate using just sound. And so they'd be paired with an experienced blind person that has been maybe blind since birth and be taught how to tell when it's safe. How to tell when it's safe to cross the street and things like that. But they wanted to be able to do that training in the safety of a lab, so you didn't actually have to go out to a street corner because that's
run over.
Dangerous.
That makes sense. That's awesome.
And so he and some of the other people in the lab, Dmitry Zotkin and Elena Grassi, developed technologies for not only doing capture but also just rendering directly to headphones this spatialized sound, so that virtual environments could be authored. And so in order to do that, the way that this technology works is it works on the principle that if we played to the brain or we played to the ears exactly what those ears would have heard if there was really a sound out in space, then the brain will be completely convinced, right? There's no difference in the input that it gets. So what we've got to do is we've got to introduce all of the modifications to a sound that would have happened in a natural environment. And that includes all the reflections off the environment, off the walls. It includes reflections off your own body, and even reflections off your ears, right? So
Sure. Okay.
Yeah.
Hadn't thought of that. But
so the ears, in fact, for us, they act as directional antennas, and they modulate the sound in such a way that it's highly directionally dependent. So it'll change depending on whether it's above you, below you, just based on how it reflects off the outer ear. And so to do this well, you've got to recreate even that ear effect, right? And they call this a head-related transfer function. And you can measure this for people. One way you can measure it is you can actually just put a microphone deep in somebody's ear and then play a bunch of sounds from hundreds. And then figure out how did they change along the way. But classically, that would take hours to do because you've got to play this sound sequentially around the person to 500 or 600 locations. So they developed an algorithm that utilizes what's called a Helmholtz reciprocity and effectively gave us the ability to do that incredibly quickly in a matter of minutes with a big microphone array. So instead of putting a speaker outside of you,
just lots of microphones all over the place.
You put tons of microphones all over the place, and you put a speaker in the ear.
And you've done the opposite.
Oh, okay.
Yeah. So then when you play something out of the speaker, you can record it in parallel. And so
you flipped it around. You got
exactly
ear, and then where are the microphones? Effectively, right? And
right. Yeah.
I know I'm the dummy, but like that seems like what it is. It's,
right.
It's the same concept, only you have lots of microphones, not just those two in the person's ears.
Exactly.
So once you knew the differences in the type of sound, depending on the space, then you could replicate that?
Exactly. So then you can add that to any arbitrary sound, right? And simulate it being out in space. And so... There we go. Exactly. And so that's now encapsulated, and that's what we spun out into VisiSonics to try to get this into the masses, into the commercial gaming, into cinema, when you're watching movies.
Yeah.
And so that's what we're working on now, and we've got a couple of examples I can
let's listen to a few more things before we wrap up.
Yeah. So here's...
All right, I got you up a little bit here.
So this takes a little while to load, and it plays a bunch of strange sounds at first. So
Listen to that.
So
That's Ernesto on the strings.
So this is another Oculus demo. So you can kick on that head.
I'll go first
display.
this time. All right, I'm seeing like a house.
That's right.
Or like a villa. Look at that fire. Did you make that fire?
Oh, there you go. And I can sense when you're looking at the fire,
So you can see what I'm seeing now.
Now the fire's
That's
to your
right.
left.
Yeah. Oh yeah. But why is it zooming in and out? Am I doing that?
Yeah, so I'm walking you around a bit.
Oh, okay.
So if I'll turn you around here, and up in the top right of the image, you'll see that box with the
Oh,
blinking
that's
red
me.
light.
Yeah.
So that's a speaker that's playing this music that we're listening to.
It's great, man. It's getting loud.
Yeah.
Hey, it's over there. I can't twist anymore. Is there somebody outside? I'm fighting with you. I'll do it. I see what you're getting at here. I'm spinning around, and it's going in my left ear, and now it's in my right ear.
Exactly.
I like your butterflies. Or
Take them outside.
Here we go.
there I go. Here, Ernesto. Here.
Oh man, dude. It's there's the there's the water right next to me, and I don't know, whatever these things are flying around. Are those bugs?
There's little
Those are little bugs hanging around. God. And it's 3D.
That's more in 3D.
I'm in a different.
It's virtual reality.
Holy shit, Adam! This is awesome. This is awesome. And now I can kind of hear the fireplace back behind me.
Exactly. So now I'm going to try. There's a helicopter.
Can we go off the
around here
ledge?
somewhere? I
Jump
can
off.
let you look off the ledge here.
All right. Whoa. Okay.
Ernesto is looking off a ledge, and he's really looking down at his crotch while he's.
I feel. This. I got a much better view out here than
Your
the
house.
Human Factor studio at the
What are you
moment.
talking about?
Wow. This is awesome. You guys gotta try this. Wait, where's the helicopter?
Wait, helicopter's flying over. They're coming to get us.
This is fantastic.
So why leave your house? Think of the vacation business you might have.
That's right.
You guys gotta try this.
They'll try it. They'll try it.
Yeah.
No,
Everyone
that's
at
right.
home
You
should-
could do virtual tourism with this too. You could take a camera, you could make an entirely virtual world.
Somebody who's bedridden.
Yeah, exactly. They could go and go to concerts.
Applications in porn. You haven't even thought of it. You've thought of that. Of course, he's thought of that.
The,
My goodness.
I was just thinking about the was it the helicopter? No, it wasn't the helicopter. But the song that you were playing, I want my music to sound this way. When I'm jogging or snowboarding, I'm listening to music. I want it to be immersive.
Yeah,
I don't want it
absolutely.
just to be any more stereo left and right. I want like something in front of me, something behind me. You could do it with this stuff.
Absolutely, yeah. So we've got some tools that allow you to take any sound and effectively remix that into any position you want. So you could take any classic music and then remaster it into 3D sound.
Man, and that was the what is it? That module that we had, the plugin, right? What is it called?
That's right. So VST plugins. We've got a plugin for some digital audio workstations that allow you to effectively
Put stuff around.
mix stuff.
That's basically what you did there, though.
Yeah, so
Yeah.
we were doing that live with a sort of real-time engine that was built into the video gaming environment. And so wherever the video game tells us that there's, the fireplace is relative to your head, we just feed that into our engine and auto mix it.
Right.
If you're doing it offline, you got a digital audio workstation, you've got your WAV file or a piece of music, and you want to make that sound like it's flying around your head, you can just slide a couple sliders and make it,
Do your thing.
yeah.
Now, when I walked outside, I couldn't quite hear it anymore, the inside stuff. But do you have it set? I mean, is it down to I walk by a window and
Yeah, so right now we're trying to do all of the physics-based simulation that we can. So
Okay.
as you get farther away, it pans naturally as you would in an environment when you walked away from a sound. You can change the reverberation characteristics of the room that you're in, right? So say you're in a glass room.
Reflects differently than
It's
a
going to
concrete.
reflect differently, exactly. And so you can set in our virtual environment the reflectivity of all the walls in the environment to make it more reverberant in a natural way, in a real physics-based way. If you got a carpeted floor, you can change the absorptive characteristics of the carpet.
So, yeah.
I think this could even change the way some of the games are made. If you can tease a player to hear something over a particular direction, and maybe you don't have, as a character, you don't see what's there. You have to go explore to see what that sound is. I mean, I think there's like a bunch of things you could mess with this thing.
No, and what we're trying to do now is basically get indie game developers up front that are going to test it out and start making some titles.
What engine again? You're coding
right
this
now
into,
we're coding this into the Unity engine.
Unity.
Yeah.
Don't know what a Unity engine is, but I'm sure if you want to get more information,
bring a gamer to
you
talk
can
about
get a
that.
gamer to talk about the round of applause for coming on in here.
Yeah,
And,
Adam.
this has really been probably aside from maybe the wine tasting.
This is pretty good.
Yeah.
This is pretty
I should have
good,
brought
man.
some wine.
Yeah,
Yeah.
we got some beer.
This was really. This was. I didn't even use the boo button once. I mean, like
No.
no. Website.
www.realspace3daudio.com and www.busysonics.com.
Tweeters or anything like that, or anything else like Twitter feeds or.
We do have VusySonics and a Facebook page of VusySonics.
Well, thanks so much for bringing this gear out.
it was my
That's
pleasure,
pretty
man.
cool looking.
Awesome.
Yeah, man.
Thanks for having me on.
Through the Noise, the business of communicating. This podcast is presented by Human Factor, providing award-winning music, sound design, and post-audio for all media projects. And Infomia, providing online strategies for associations and institutes, ensuring their projects get noticed.